As we record this, November is rapidly drawing to a close, and with it, Movember. Cybersecurity is unfortunately becoming all too synonymous with feelings of stress, anxiety, and burnout. And many of us across the industry, from CISOs to security engineers, are feeling the effects. Whether it's fear of losing a job, not wanting to appear weak in front of others, or just the high expectations we all put upon ourselves, many of us struggle to say how we feel. Men in particular are very good at bottling things up and just wanting to get on with it and not cause a fuss. But without a release, stress can be devastating and is often called the number one killer, linked to many leading causes of deaths, including suicide, to which we lose 60 men every single hour. Last year in the security community alone, 45% of security professionals said they wanted to leave not just their job, but the entire industry because of feelings of stress and anxiety and burnout. Movember supports charities all across the world, providing support to men going through all sorts of difficult times, from dealing with physical health problems to mental health concerns. And if someone you care about appears to be going through a tough time, bear in mind they may not feel comfortable bringing the topic up, even if they really want to talk about it. The first step to helping and supporting those is just reaching out. Thank you.
Welcome to This Month in Security, a DevCentral podcast featuring contributions from Aaron Brailsford.
You know, it is relatively easy to breach an organization because usually soft, fleshy things.
Malcolm Heath.
Just from a basic sort of security perspective, it's better to fix things earlier than later. It's better to structure your architecture and stuff that it's in such a way that it's secure, rather than trying to bolt security on at the back end.
David Warburton.
What really fascinates me from a security point of view, I like to kind of get geeky and nerd out about crypto stuff and all the latest technologies, but actually so much of security, like probably the most pivotal part of security is trust.
And Sander Vinberg.
The level of these guys was very high. Everybody in the room was kind of a hot shot. It was pretty wild to just be listening to discussion at that level.
I'm your host, Aubrey King with DevCentral, and we've got a great show for you today, so strap on those earbuds and get ready for This Month in Security.
So this month in security, I had a chance to sit down with Sandy Dunn, a CISO that I know from my time with OWASP, and I wanted to talk to her a little bit about a project that she's been working on, the AI Security and Governance Checklist. So we'll get to talk to her in a little bit. We also wanted to welcome back David Warburton to the roundtable this month, and we're going to get the scoop on Sander's latest release from Labs. First up, though, we want to check out a quick video that I did in a live stream. Actually, I shouldn't say I did it. It was all Aaron. That Aaron did in a live stream recently about request smuggling. So what is it?
Request smuggling. This is going to be a sort of primer on request smuggling because, like I say, it's a big topic. Let's say that I'm the attacker and I want to exploit request smuggling against a target. Maybe I want to get to a resource that should require authentication without providing a username and a password. So me as the attacker, there's my little laser pointer, I will send two requests. I will send a post request, which goes to the login page. That's an unprotected resource, right? I don't require any authentication to get to it. The body of my post request, where you would normally see username and password, will actually be a GET for a protected resource. Now remember, that's the body of the post. So it's not a second request. It's just data within the post request. And then I'll send a second request to another unprotected resource, like favicon.ico, right? It's something that anyone can get to. You don't need any authorization to get to it. So I send those off. Now, for smuggling to be exploitable, like we just said, you kind of need a front end and a back end. And basically in all cases of smuggling, you need a front end and a back end. Now in this example, the front end is going to handle all of the authentication and authorization tasks, and the back end is going to be servicing the actual requests. So you could think of this like a microservices architecture or something like that, where you have a system that is making sure that someone is authorized to get to a resource, and then another system that's actually going to do the heavy lifting to get the data or whatever it is that the request is asking for. Now, my target's front end understands these requests in the same way that I sent them. So it understands this as a post for an unprotected resource, and it doesn't even look at the body content of the post, because all the front end cares about is, am I supposed to be able to get to login.php or not? And it sees a second request for favicon.ico, which again, all it cares about is, am I supposed to be able to get to that resource or not? And the answer for both is yes. So it sends them on to the back end. Now, and here's where the problem happens. The back end understands the requests differently to the front end. That's the key to request smuggling, is always that you have two systems. They disagree on how to process what they receive. The back end sees a post request for login.php, and then it sees a get for the protected resource. And the get for favicon.ico just kind of gets glued onto the end of this get, kind of gets swallowed into the smuggled get. Now, like I say, the back end assumes that the front end handled all of the auth. So even though this is a protected resource and I never supplied any credentials, the back end doesn't care, because it thinks the front end took care of that. And what it will do is send two responses back. It'll send the PHP for the login page, well, the HTML actually for the login page, and then it will send the HTML that belongs to the protected resource. So it's satisfied these two requests. They go off to the front end. Now the front end, remember the front end saw two requests, right? It saw a post, and this get was just part of the body content, and it saw a get for favicon. So it's expecting two responses. It's expecting some HTML for the login page and an icon, but what it actually gets is the HTML for the login page and the HTML for the protected resource. But again, the front end doesn't care. It sent two requests and it got two responses. So as far as it's concerned, it did its job. They're both for unprotected resources as far as it's concerned. So it sends them to the client. And the client is the attacker in this case. And what the attacker gets back then is a response with the login page and the protected resource response. And I have successfully bypassed authentication by smuggling my get in the body of a post. Now that's, in a nutshell, request smuggling. Exactly how you smuggle the get in the post varies depending on the systems you're attacking. It's going to vary depending on the combination of systems that you're attacking, in fact, the front end and the back end. It will almost always involve careful manipulation of two headers. The transfer encoding header or the content length header. Those two headers tell web servers, proxies, caches, everything, how they should understand the body content that goes with a post request, how that body content should be encoded and how long it is. And smuggling is possible when these two systems, the front and the back end, disagree on how to handle those headers. So maybe one system ignores a content length header if there's leading white space in front of the header name. Right? In which case, let's say the front end ignores the leading white space, it thinks it's a 0-byte post because there was no content length. But maybe, and that's not the case, right? There was body content. Maybe you send both headers, transfer encoding chunked and a content length. And one system honors the content length header and the other system honors the transfer encoding header. And again, you get a disagreement between the front end and the back end on how they should pass that post request, and strange things may happen, right? It's highly dependent on the systems you're trying to attack, and it requires a good deal of investigation on the part of an attacker. But this investigation is pretty well understood at this point. This technique has many variations. It's been documented quite well over the years now by folks like James Kettle from Portswigger. Portswigger make Burp Suite. Burp Suite has a whole bunch of things built into it to try and find request smuggling vectors. So if you want to inspect your own systems, Burp Suite is very, very good tool to use to find this. It's been documented by research groups like Praetorian and Malicious Group, and there's way too much to cover in one slide. But that's a good overview, I think, of how request smuggling works.
Yes, the wisdom of Aaron Brailsford. That's something I've come to rely on pretty heavily through the past year and a half of doing this with these guys. And we're going to get to a little bit more of his wisdom in a moment. And we're also going to explore Sander Vinberg's latest piece for Labs. But before we do that, I wanted to give a special shout out to David Solomon. Thank you so much, David, for the feedback on the podcast. We really appreciate it. And I want to ask you to please let me know how we did this month. Now, before we get into the roundtable, which is coming up right now, I'm going to roll a very quick transition segment and bring the guys on.
And here we are. Thank you, Aubrey, for introducing us and saying such nice things about us earlier. As always, we've got a roundup of a few bits of news to talk about, and just 3 topics this month that we kind of pulled out collectively from what's been going on. I'm actually going to start with something that I think is one of the things David is passionate about, C2PA, the Coalition for Content Provenance and Authenticity. So this was kind of new to me, David, when I started researching for this episode. The way I understand it, it is a spec for a system that will allow you to attach some metadata to images, videos, or audio to prove that that hasn't been tampered with. So to me, it sounds like a sort of tamper-evident EXIF data, like for pictures.
Yeah, I'd say that's pretty much it. And I think, we've had schemes like this for various different security requirements over the years where we're not too worried about privacy or hiding something, so we don't need the encryption. We just need to prove if something's been tampered with. So exactly as you said, Aaron, this is all about proving to consumers, the kind of everyday users of the internet, readers of the New York Times or BBC, that an image they're looking at, a piece of digital media, whether it's video or audio, is either genuine or has come from a certain source. And that's where things get a little bit kind of murky. It's particularly of interest when we think about the amount of content that's been churned out from generative AI systems, not just the text-based like ChatGPT, but DALL-E and Stable Diffusion creating images. The new versions of Adobe have now got generative kind of AI fills in them. So, to the average everyday kind of reader, we're sat back thinking, well, how do we know what's genuine? These images, these digital media assets look so genuine. How can you tell where it's come from? And that's exactly where this kind of spec has come from. And it's legit because it's got a number in there. They could have called it CCPA, but they've called it C2PA instead. So it's come from the likes of like a joint venture from Adobe, the BBC, Microsoft, Intel are involved, and even hardware device manufacturers like Canon and so on. So the idea is at every stage of an image or digital asset creation, provenance, as they call it, is kind of, as you said, kind of tagged and then cryptographically signed. There's a hashing process, which means the signature can be applied to a smaller bit of data rather than the whole thing. But it means that when you, in theory, go and look at some digital media online on a website, you will see a little watermark, a tag, that you can hover over and you can see, and it breaks down all the different aspects of that digital media's life and journey. The camera it was taken on, including things like GPS location of where it was taken, the bit of software it was used to kind of manipulate or perform it, perform operations on it. And this is all eventually signed by a publisher. And so you can see the kind of breakdown and see who signed it. So in theory, it sounds super useful. And I'm genuinely interested in it. I think crypto and trust, as anyone's kind of listened to me waffle on before, I've always gone about trust and the kind of importance of cryptographic, algorithms and primitives to kind of sign and provide that kind of element of trust. But I also see an awful lot of potential pitfalls with this kind of scheme. I mean, to me, does the average everyday user know to look for this kind of watermark? I mean, it's still a brand new spec. It's yet to make its way into wide deployment. But I think for me, anything that is optional will have inherent problems. And then, we see this, for any of us that work on kind of secure websites and TLS, we might implement TLS 1.3, but SSL 2 and 3 until recently was still optional. And it's those optional kind of parameters that make this kind of thing dangerous, I think. The couple of kind of pitfalls and examples I see in this environment or in this kind of situation would be, how does anyone individual, even security professionals, know what a trusted publisher should look like? I mean, I often talk about the problems we've got with email and kind of phishing, because a legitimate organization might use dozens or hundreds of different domains to load assets from, or to send, user questionnaires or send emails from. So, all right, I might go to Amazon.com for my shopping, but they might use, a dozen different domains and partners. And how do I know which of those is actually legit and trustworthy and not? Another example I can see is, I'm sure many of you are familiar with the kind of fake Google or fake even LastPass kind of pop-ups. So a website could literally use JavaScript and code to make a very genuine looking login screen, but it's not a genuine login screen. It's just faked and it's all done. Well, exactly the same problem could in theory come about, that the watermark essentially could be faked. How does the average everyday user know that that's a legit watermark and one that's faked?
Yeah, it's an interesting problem to try and solve. The first thing, so I went to the C2PA website and I watched their little primer video.
Yeah.
And they have an example that's like, this is Bob. I don't think his name was Bob. This is Bob. He's taking a picture in his Android phone that's using this app that will automatically put the data, attach the data, sign the data and glue it on there. And he takes a picture of the Brooklyn Bridge. Well, my first thought was, that's great, but EXIF data is commonly stripped from images specifically because of privacy concerns, right? And now you're telling me that the goal of this thing is to put the GPS, all of these identifying things, and then sign them and make sure they can't be removed. It talks, about solving that problem, right?
There is a distinction, to be fair. Now, from what I understand, lots of those things are optional, which again is fine, because actually from an anonymity and privacy point of view, fine, you could maybe hide the GPS or the kind of publisher or the kind of, whatever public information, personal information you might want to hide. But, you can even have anonymous kind of publishers. But removing the EXIF data, removing that kind of tag is completely legitimate. So really all that's happening is it's putting all the onus onto the end user, the kind of a consumer, the browser, the web, what have you. Now that is probably the right thing to do. But again, my argument is I don't think the vast majority of people will have the skills or the knowledge to know what is genuine. Who is a genuine publisher? Is it okay? Do they even know what a piece of software is called? So looking at this kind of breakdown might be useful for those that have the skills and the time to do so. I'm not sure it's going to help for your average user. One of the kind of key contributors to this spec was the BBC, and they have a big thing ongoing at the moment where they have an entire team now that spends time looking into the veracity of digital media and various claims. So, skilled individuals and researchers such as that will absolutely have the skills and time to look into it. I'm just not convinced it's going to help the vast majority of everyday, browsers of the web.
Yeah, it's a very tough nut to crack. And it's like you say, it's got so hard to spot fake media, right? AI has finally learned to put the right number of fingers on people's hands, for example, usually. So, and the right number of hands on their bodies. Like, usually you get 2, not 3, which is always a bit suspicious. And it will continue to improve and get harder and harder to distinguish at a rapid rate from real life. So, absolutely. Yeah, this is going to get worse before it gets better, I think, is a problem. Yep. Thank you for that primer on that. What else happened this month? Well, CVSS v4 came out very recently, which is quite a sort of revamp of CVSS. For anybody who isn't familiar, you probably all are. CVSS is how we score vulnerabilities, so that people can better assess the risk of a vulnerability than just a vendor saying, low, medium, high. Obviously, it maps back to words, but it gives you quite a granular score. Vector behind a score, I should say. And CVSS 4 introduces a whole bunch of new vectors like attack requirements, so that you can more easily deal with scoring things that require a race condition, for example, to be exploited. Supplemental systems impact was interesting to me because it means that you can better score things like request smuggling, where the impact to confidentiality, integrity, and availability isn't necessarily on the proxy that's handling the request, but the system behind the proxy that's handling the request. I don't know if either of you have had a chance to review it, if you've got any thoughts on whether this is going to make things better, worse, or just more complicated.
Well, I would say that the ongoing evolution of CVSS scoring is fascinating to watch. I mean, CVS v2 and CVS v3 scores are often very different from each other. And that's down to perhaps CVS v3 being a more granular, more accurate in describing the specifics of a vulnerability than v2 was. I'm hopeful that this will cause another level of accuracy. I'm especially interested in seeing that they included provider urgency, vulnerability response effort, and score for automatability or automatable in there. I think those are probably really, really good additions. Additionally, there's recovery too, which I think as a previous roles being a responder to these kind of things is an interesting score that I want to read more about. The one I'm really not sure about is value density. Do you know what that one is, Aaron?
I don't. That was the one that I was looking at it earlier. Like that is I understand the words, right? Value and density, but I don't really understand what it's getting at. The other stuff is much more easy to understand.
The interesting thing for me is going to be the kind of lowest common denominator, which I mean, some of the work we did recently, Sandra actually co-authored the evolution of the CV landscape, in which, one of the big questions we looked at was, are CVEs getting worse, by which we meant our CVSS scores getting worse. And generally speaking, the answer was no. It's just that CVSS 3 scored higher than 2. It's just the way it was rated. So I wonder whether we're going to get the same kind of confusion almost in the industry where the actual scores from CVSS, which most people I think will look at. They won't necessarily look at the detail and how that score was made. They'll just look at the number, and then big assumptions will be made in terms of the severity or in particular how it compares to CVSS 2 and 3 scores.
Yeah, I see that problem a lot. People only looking at the number and not the vector to really understand what's going on behind it. Two interesting things actually is that I did some sort of practice scoring on some of our existing vulnerabilities that we've disclosed. And you get more granularity when it comes to critical vulnerabilities. Some of them drift down in severity slightly, and I would say maybe more realistic in score. Everything doesn't come out as a 9.8, which really flattens the scoring a lot. I do find it interesting that the supplemental metrics, so the things you were just talking about, Malcolm, value density and so on, don't adjust the score, at least as far as I can tell. None of them adjust the score, they only adjust the vector. So they're only going to be useful if people are actually looking at the vectors behind the score.
Actually paying attention to it, yeah.
Yeah, and I suspect you'll find a lot of vendors don't use the supplemental metrics. Like we as F5 with CVSS v3, we don't use the environmental or temporal scores.
Right,
Vectors,
because we don't know how they're going to apply to a given customer environment. Yeah, so maybe that's a little bit inside baseball kind of stuff, but still, I like the addition of them. I think that giving people a framework that is pre-existing that lets them maybe start to try to really figure out how a vulnerability applies to their specific environment, much as those same scores did in V3, probably is going to be a really good addition, at least for the people who are going to want to try to use it.
Yeah, I agree. And I really like the supplemental metrics. I just wonder how often they'll be used. But we'll see. We'll start to see, I guess, people move towards CVSS v4, ourselves included at some point, and then we'll see how it pans out. And that's when you really iron out all of the wrinkles, as we found with 3.0 becoming 3.1.
Yeah.
So the last thing I had to bring up this month, if we move on from CVSS, is two processor vulnerabilities that were disclosed. One is called Reptar and the other is called Cache Warp. I mean, they have CVE numbers as well, but we'll stick with the names because they're more catchy. Reptar being Intel specific and Cache Warp being AMD specific. Both common in that they are going to be the biggest concern, in fact, in terms of cache warp, probably only really a concern to people doing virtualization. And I think realistically that means cloud operators, public or private, who have little control in workloads running in their virtualization space. So I did a quick read up on Reptar the other day. Actually, I wrote about it in This Week in Security. It affects Ice Lake processors and later for Intel pretty much. Sort of 6 or 7 different processor families there. And it was discovered by Google and another researcher, so Tavis Ormandy. It affects the rep mov sb instruction. So just to explain that, and then we can give our views on it. Rep stands for repeat. Mov sb is move string byte. That's basically how you move stuff around in memory in Intel instruction set. Rep is a prefix. Mov sb is the instruction. There are other prefixes, and this particular vulnerability involves the rex prefix, which is what lets modern processors, remember x86 goes all the way back to the 286 and 386, lets modern processors access more than 8 general purpose registers. It's basically register extensions. And this vulnerability, actually in common with cache warp, happens because we improved processors. We added a new thing in Ice Lake, which is fast, short, repeat move, to try and make moving memory around more efficient. And that's what's being exploited when you have a fast, short, repeat move happening and you have an invalid extension in front of the instruction. The processor goes into a kind of loopy state. And it's been proven, at least, that you can use that to crash the host system from a guest, from an unprivileged guest. And it's theorized that you could use it to read memory outside of your guest's container. So, virtual machine escape, guest escape up to the host and hypervisor level. That's the latest in a long line of processor vulnerabilities, and their commonality seems to be their most useful feature is escaping a guest, right? This strikes me as a massive problem for people running clouds in terms of patching this stuff. There are fixes available for this, right? But it's in CPU microcode. I have never had to try and patch a whole bunch of CPUs and a whole bunch of hypervisors, or a whole bunch of hosts, I should say. But it strikes me that this is not an easy thing to do at large scale.
If anything, is actually easy to do at large scale. I'm happy to hear that there's microcode patches available, and I'm sure that the major cloud providers are scrambling their teams to start dealing with this. One thing I just wanted to mention briefly is, of course, that CPUs exist in an awful lot of things other than cloud environments. And these classes of hardware vulnerabilities or CPU vulnerabilities affect all sorts of things, IoT devices amongst them, embedded controllers of various different kinds, PLCs, computers that control manufacturing equipment that often are extremely difficult, if not impossible, to upgrade or update in any way, much less, installing new microcode. Possibly even causing them to have to be recertified, at some level, even if you're going to do that at a cost of probably, amounts of money that I'm never going to be able to see in my life. So, certainly these are the most immediate impact is definitely towards cloud environments, but there's going to be, I think, a long list, and I'll be very interested to see how attackers start to leverage not only these, but also previous hardware attacks when it comes down to doing things like affecting microcontrollers or IoT devices, maybe in the context of an OT pen test or attack, or finding yourself in an environment that might be pretty locked down, but maybe there's some IoT device in someone's office that you could penetrate and pivot from. I'm going to be watching this space carefully, I think.
I think it's easy to kind of look at these vulnerabilities and think these are just kind of insanely difficult vulnerabilities to actually exploit in the wild and actually pull off. And that might be true, I think. That still might be of concern to a lot of organizations. Their primary adversary might be nation states, but The nation states are those people that have the resources and the skills and the time to put those kind of attacks into practice. But as we've seen, attacks only ever get easier. So today it might be nation states with the ability to do it. Tomorrow it might be a simple app available on the dark web that anyone can kind of run and exploit. So I think very much it'll be a case of it's maybe not scrambling around hair on fire just yet, but it's something that everyone will need to kind of pay attention to.
Yeah, I think that's a really, really good point, David. I mean, I think that, correct me if I'm wrong here, but if I remember when Rowhammer was first being discussed, it was something that was presumed that you would need to have local access, like direct access to the device in question or the device under test. And it was considered to be, achievable, but difficult. And then within a relatively short time frame, I want to say a year, maybe two, people were demonstrating that you could actually do useful things with that technique over the internet from a browser, right? So I'm never going to bet that something that just because a vulnerability exists and the initial assessment is this is going to be hard, that somebody isn't going to rise to the challenge, right?
Exactly.
Because it seems like we have a long track record of people doing exactly that.
Yeah, if you look at Spectre and Meltdown, right, the speculative execution attacks. Last month we had eye leakage disclosed, which is browser-based Spectre on Apple devices, presumably Apple Intel Silicon. I haven't actually gone and read the write-up about that, but yeah, that was Spectre and Meltdown. This would be really hard to carry out. It's not a big deal. And then, okay, we're probably 2 years after Spectre and Meltdown at this point, but now you can do it in a browser with JavaScript. It's, yeah, people put time and effort into these things. And I tend to think that if it's public knowledge that you can do this in a browser with JavaScript, it's probably been private knowledge for longer.
Could be.
Back to those nation states. The last thing I was going to say about these two is actually Spectre and Meltdown. Everything from that point onwards, almost all of the Intel or AMD vulnerabilities and ARM vulnerabilities that have come out, they all exist because of improvements. Right? The speculative execution didn't exist back when processors were in their infancy. Well, not really their infancy. They'd existed for a long time, but the original x86 architecture, and that wasn't a problem. And we chase performance, and chasing performance comes with drawbacks, apparently. And we are all addicted to the performance, not just because we want
performance
snappy
and features. I mean, if you're not careful, you'll get me started on my email rant again. I'm constantly talking about, I spoke to my colleagues recently about trying really hard to go to plain text email, and it's just impossible in today's kind of workplace. Whether you're Microsoft 365 based or otherwise, everything is so tightly integrated and kind of depends on kind of deep links, things being automatically embedded into emails, and literally entire workflows can break if you go to plain text. So we kind of put all these features in that we're now completely dependent on, and we're having to come up with more and more sticking plasters and kind of band-aids to fix the things that we've invented to create new features.
Well, and specifically the AMD ones, the
cache warp.
Cache warp, thank you. The cache warp one is specifically leveraging processor features that were meant to protect virtualized environments, right? They were meant to ensure integrity and confidentiality of guests running in hosts, and those very same features were the ones that are being used by confusing cache lines, as I understand it, to actually allow for code execution within guests from hostile hypervisors.
So
and a number of other things, right? Yeah.
It's secure encrypted virtualization, secure nested paging is what's being leveraged, which you rightly say, specifically introduced to better manage encrypted guest memory to prevent a malicious hypervisor from accessing it. And that is exactly how a malicious hypervisor can access the protected guest memory. So something of an own goal, but it's the way it goes with new features and functionality, right? It's just that these new features and functionality are baked into processors, which is tricky. Not as tricky, like you say, about all the IoT devices that are going to be, if not difficult to patch, unpatchable, which gives me a nice link into the next segment, I think, into Sander's report, which I believe the subheading of was the unpatchables. So, not that it was specifically IoT devices. I think it's time for us to hand back to Aubrey so he can bring Sander in.
Hi, guys.
Hey, Sander.
Hey, Sander. So, you have a report out.
I do. Yeah. After after a lot of work and some delays, we just published a report on the 1st of November, which is a new one for us. We had been, until 2022 or through 2022, we were publishing a single sort of report about application security. And last year we decided that the findings in the last report sort of indicated it sort of made more sense to split out analysis of web exploits and vulnerabilities from attacks against credentials and access control and kind of everything involved in that sphere, which we decided to sort of treat as an identity threat report. So what we just published on the 1st of November is the 2023 identity threat report. And there are lots and lots of ways that people attack identities. And I think that the ways that we're using digital identities in workloads is changing really quickly. Not all of these different ways are represented in the report. What we ended up really focusing on was credential stuffing, phishing, and the growth of techniques to bypass multi-factor authentication, which is a trend that we've been sort of keeping an eye on for a few years now.
Yeah, that bypass of MFA has become commodity essentially lately, right? That's how
it seems to us. Yeah.
How much of a problem would you say that it's become, Sander? The kind of MFA bypass, is it really just affecting a small number of organizations and potential target victims, or is it pretty much ubiquitous?
I would say it is potentially ubiquitous in the sense that at this point it seems that MFA techniques that are built around one-time passwords, 6-digit codes, pushes, or sort of allow things that we get on devices or in email or stuff, all that can sort of be treated as vulnerable now, particularly to the growth of a sort of a new type of phishing called reverse proxy phishing or real-time phishing proxies, depending on whom you're talking to. And real-time phishing proxies are not new. David, you wrote about these a few years ago, I think in 2020 Absolutely. Or 2021, and Evil Gen X was published in 2017. So there have been sort of public frameworks for building your own real-time phishing proxy for 6 years. But what we found through some dark web research is that whereas these would have been sort of advanced or niche techniques 5 or 6 years ago, at this point, no self-respecting phishing attacker would bother running any kind of phishing framework that didn't have this kind of real-time capability in it. And the reason why this is so damaging is because, it's sort of right there in the name, right? So a real-time phishing page, a landing page that is spoofing the site that somebody's trying to log into, will essentially take the credentials that they're passed by the victim user, use those to auth to the site immediately, which will then provoke or sort of trigger the normal MFA process. And so the user feels that they're going through the exact same MFA process that they're expecting, right? What that means is that something as simple as a one-time password, a 6-digit code that doesn't have any sort of kind of origin or signature associated with it, that's just another thing that we just gave to the attacker. They pass that right to the origin server, log in, and then often they'll change that password right then, and then your account is compromised. So the real-time phishing proxies, I think, are the largest threat to most MFA frameworks out there today, just because phishing is a very scalable and sort of easy to implement type attack. But we've also seen attackers using malware to get around it, which is a little bit less scalable because you have to get the malware onto the device. But the flip side of that is that a lot of the malware that we're seeing is a lot more versatile than a phishing framework. And they're also extracting tons of other really sensitive information, including cookies and other kinds of tokens, crypto wallet information, stuff like that. So the third kind of MFA bypass approach that we've seen is the use of social engineering. But this is, I think, a little bit less dangerous because that has, as a prerequisite, you already have to know that you have the correct creds. Otherwise, you don't necessarily know when or whom to social engineer, right? So for me, it's really the malware and the rise in real-time phishing proxies and the sort of commoditization of real-time phishing proxies. That's why I don't think that one-time passwords and 6-digit codes have a lot of a future.
Yeah, just as a clarification there, Sander, when you're talking about social engineering and needing to know the correct creds, right? I just want to make sure that I'm understanding. So if I have a cred set for a particular user, and I know who that user is, and I can figure out some way to get in touch with them, then the social engineering part is coming up with a pretext to be able to say, "Hey, we need the 6-digit code that just landed on your phone."
Mm-hmm. Exactly.
Or something along those lines. Okay.
Yeah, and the head of the threat analytics and reporting team, Tafari Mwandi, who is a sort of encyclopedia of fraud techniques, he shared this pretty amazing approach that I mean the fraud always kind of makes me laugh because the creativity involved, but it was an automated thing. So as a victim, you would get a phone call and it would say, "Hey, Sander, it's your bank. And we just detected that somebody bought," and then they tell you something really expensive. They just bought $5,000 plane tickets, first class to Bali or something. And if this is a valid charge, press 1. And if it's an invalid charge, press 2. And naturally, everybody's going to say, "Oh, God, I didn't just spend $5,000 or $50,000 or whatever." So they press 2 and they say, "No, I'd like to dispute this charge." And then the automated framework will say, "Cool. In order to verify your identity, we're going to send you a 6-digit code. Please enter it into the thing." And then they log in with the creds, trigger the MFA, get the 6-digit code, and then the user says, "Well, I don't want to buy that MacBook Pro or those plane tickets or whatever." So they give the 6-digit code over. So yeah, so that's exactly how it works. Once they know that they've got the right creds, then they'll go after individual users and essentially fool them into giving up the code that the attacker needs.
We've been talking about, it feels like we've been talking about cred stuffing in the kind of industry for years and years and years. And we kind of like to think that most people know what cred stuffing is by now, and it's kind of a solved problem. But in all the kind of research and work you did, looking at, I think, something like 3.7 billion requests or something crazy over a 12-month period, what were some of the maybe more unique or interesting things you discovered about cred stuffing, some of the things that maybe surprised you about the way attackers were trying to use those creds and attack logins?
Yeah, well, actually, it was 320 billion transactions that we
looked at. There you go.
Of which 60 billion were evaluated as malicious. So not all of those were credential stuffing attacks. A lot of those were regular users. But we in the report we tried to break down these threats by kind of 3 different metrics, which is kind of the standard way that I've arrived at to communicate about a threat, which is prevalence, targeting, and TTPs. And so what we were able to do was kind of establish some kind of basic average value for how much traffic on an authentication surface an organization can expect to see that is credential stuffing. But we were also able to break down credential stuffing traffic by the sort of approximate sophistication of the attacker. And so I was actually really surprised to see that on average across 159 customers, 320 billion requests, about 65% of credential stuffing traffic was just really basic HTTP requests, no browser, no JavaScript, the sort of thing that if organizations are looking at their traffic, it should be actually pretty detectable stuff. So I went into this expecting to see the sort of the latest and greatest in terms of attacker techniques, and we saw some of that. The flip side is 20% of that traffic on average was advanced stuff with kind of realistic mouse movements and keystrokes and stuff that's really, really good at looking human. But almost 2/3 of the traffic we saw was just really basic. And so the first thing that tells me is we could be doing better in the fight against credential stuffing if we wanted to. And there are a lot of attackers out there that are sort of putting in a rather minimal effort.
Well, yeah, I mean, we kind of say, don't we, that attackers generally will only put in as much effort as they need to. So clearly, if there's a lot of fairly basic, low sophistication kind of attacks, that would imply that it's working in a lot of cases.
Mm-hmm. Yeah, and so we also broke down that sophistication by different industries, and it was kind of interesting to see. You could tell across the board that once you sort of turn on an anti-bot solution, you start dropping this traffic, there's always a shift towards greater sophistication. But it sort of went in slightly different directions depending on the sector. So some of the most highly targeted sectors, like the travel and the telecommunications industries, which had some of the highest sort of average rates of malicious automation, also had the lowest rates of sophistication. So the travel industry is just getting hammered with really, really low sophistication cred stuffing. I think it was like 95 or 98% was just this basic HTTP stuff. That was it. I mean, it's a sort of cred stuffing that you could pull off with Burp Suite, the tool that you were just talking about, Aaron. On the other end of the spectrum, the finance industry and the tech industry actually had a larger proportion of advanced automation before you start mitigating any traffic. And then a lot of those folks gave up, and the sort of what we call intermediate sort of took the lion's share. And that sort of tells me, if I had to guess, I would say the absolutely most advanced and the sort of most nuanced attackers are going after finance and tech, because I think that those are the folks that realize when even their advanced techniques are getting mitigated, I think they give up and they go attack another target.
I would guess that probably speaks to the how advanced the protections are in those industries.
Absolutely.
Right, the financial industry has a lot of money poured into fraud detection, and that extends to anti-credential stuffing, whereas maybe those other industries are not quite as advanced.
Absolutely.
Super interesting report, though. I think highly worth going to read for anybody that's listening to us, and because we can't possibly cover it all.
No, we can't.
But thank you, Xander, for coming and talking to us about it. It's a really interesting topic, and there's a ton of data that you analyzed to produce this report. So a lot of work went into that.
Sure did.
On that note, speaking of a lot of work, we will pass back to Aubrey to close us out.
Thanks, guys, and thanks, community. I hope you enjoyed the new format of our roundtable. We're trying a couple of things to just change things up, and we hope you liked any of the transition that you see. So for our final piece this month, I had a chance to catch up with Sandy Dunn, who's a CISO and also a member of the OWASP Top 10 for large language model applications. No surprise there. I tend to hang out with those folks these days. She's putting together something fairly special called the AI Security and Governance Checklist. So let's see what she has to say about all that.
Welcome to my office. This is where I work in this studio. Normally I see you at the OWASP Top 10 for large language model applications. And I'm psyched that it's funny. We talked about the checklist for security and governance. That's been your project for the most part that I've seen since I came into the project. I thought that would be something as our community begins talking about AI applications and how to deploy those in the cloud in their data centers and things like that. I thought it'd be really, really impactful stuff to bring to my community. So before we kind of get into the nitty gritty of what it is, I'm curious to know, what is it that drove you to want to have this sort of checklist? What motivated you to really get this thing done?
I think it's something that we share in our OWASP group. We're really a lot of architects and developers and practitioners. There's a few people that have deep machine learning and artificial intelligence background, but the majority of us are people who have been trying to protect organizations and develop for organizations for a really long time. And when ChatGPT came out, we all shared that same level of, this is the most amazing thing ever, and this is the most terrifying thing ever. And so when ChatGPT first came out, I actually didn't get super involved with the hype. I mean, we've been through so many hype cycles, and artificial intelligence, I can tell you, I mean, it took about 2 prompts, and I was just like, oh, wow, this is amazing. And I thought, this is finally something that we could use to accelerate the maturity and get to the place that we want to get. I mean, it gets rid of so much of that really difficult work that's manual and drudge and not very fun. But then on the other side, what I saw was people really trying to recognize that it was completely different way to use technology. Even now, I'll go into like a CISO meeting group and they're talking about, oh, well, you just have to set up filters and firewalls. And I'm like, no, that's not all you have to do. And so the motivation for the checklist was to help people really be able to grasp as quickly and as simply as possible the nuances of trying to use this technology. I hear people going, well, we're just blocking it. We're blocking it. I'm like, probably not. I mean, it's just everywhere. There's so many plugins. There's so many different versions. There's so many different ways to use it. And I don't think that's successful. I think that you want to understand it, but you do want to have some level of understanding where it's going. So trying to address those two extremes of saying, oh, we're just not going to engage. We're not going to use it. We don't see the benefits. And, oh, we're all in. Be strategic. There is some things you need to think through. So when I was first trying to wrap my head around it, I created the AI mind map that I was like, okay, here's all of the things that you need to think about, even from like a legal perspective, even though we don't have a law around artificial intelligence currently, a national law. A lot of your privacy laws have direct implications around artificial intelligence and how you use it and how you deploy it. Different rules like in industry where you have to have a human in the loop. You can't necessarily just send people to a chatbot. So helping people, the legal implications of code and warranty and licensing and insurance, like all of the things that before you actually bring this into your environment, there's some nuances to it that you want to think about.
Yeah, the cool thing about the document, having read it, and by the way, for anyone in the community, obviously, that hasn't read it, we'll have a link that'll be there for you. But having read it, it's nice because a lot of the justification for it is really upfront. And it kind of gives you the rationale behind what is this thing? What's it for? Why are we doing this? And then gives you the checklist. I really kind of appreciated that. I expected as I was opening it, I'm just going to have a checklist. But man, it was a whole lot of data and really informative for me, even when I'm typically in this stuff all the time. So I guess the question I have about that is, who do you feel that the checklist is aimed at specifically? Is it really fairly broad, or is this typically for kind of C-level or operations? What do you think?
Yes, C-level for sure. Your head of legal, your CISO, your privacy officer, insurance, your CEO, who is getting pushed from all of his people are saying, hey, we absolutely have to have this in our environment. I tried to keep it simple. I've rewritten it several times. I mean, Steve laughed at me because at one point I had it at 40 pages long. It's like, that's a lot of explanations, Sandy. I was like, yeah, that's probably too simple. The other piece that I tried to include in it is, even though we're all agreeing that large language models and generative AI brings kind of a new type of attack into our environments, a new thing we need to consider, a lot of our old processes and a lot of the old ways that, or the traditional ways that we're looking at our environments are effective. So in there, you'll see a whole list of OWASP tools where people can go and get additional resources, and also MITRE. So I really tried to keep it open source where it was freely available, and people could go out and check out those tools to improve their environments. One interesting thing about the different machine learning people that I talk with is they're really pushing SBOM. They're really pushing the CI/CD. So I thought, oh, wow, you could raise the water table across your entire environment by incorporating these best practices for everything.
It's funny you mentioned SBOM. One of the things that I've been paying attention to recently is the OpenSSF, which is a Linux Foundation initiative. And that's one of those things that they talk about quite frequently, is kind of the necessity of SBOM and knowing exactly what's in your environment from a software packages perspective, because that really is one of the really scary threats today. That's like an easy way for a threat to get involved in your enterprise. The number of times we've seen, my son actually, he had to do a cybersecurity thing for school and said, I need to bring in an example of how cybersecurity could be involved in warfare. And I went, okay, SolarWinds. You just need to look at that. And that was really an interesting example of how the software supply chain ended up impacting things. And if they had only known that
that code stream was infected. Well, the same thing is much, much worse for an open source library. I mean, in a library's project lifecycle, the number of heads that walk through the door is tremendous. And really, you don't know who's really running one of these things. It could be any library gets taken down at any time. So yeah, it's just something that I've been paying attention to. They have an AI working group as well. I ended up putting their working group on my calendar. Not that I could do it before Thanksgiving, like everything's been crazy for me, but I think after Thanksgiving, I'm going to start hitting those meetings pretty regularly as well.
Yeah, I actually about it too, Aubrey. I posted kind of a celebration of some of the work that the Open SSF are doing in the people, the projects that they've assigned. Trying to give more visibility. I'm not sure that people realize how much free, and again, I use that word. We all know that it doesn't mean that it doesn't require work and effort to kind of get it into your environment and start using it. But the tools available around SBOM in improving your environment, they actually have a whole document on how to start using it and scoring your maturity and strategy around using the Cyclone SBOM tool that they have in partnership with Open SSF. So as challenging as it is to do security, we have made amazing progress.
Absolutely. Where do you see the checklist going in the future? I know it's too early to say because we're not actually released yet, right? Like we're still in beta.
And the first version is a 0.05 version. I'm releasing it out into the community to just get feedback, have people say, hey, this was useful, or it would be more helpful if we had more information around this. Initially, I put quite a bit of regulatory information in there. And I actually, because of another working group that we have within OWASP, the AI and privacy group that is focused on that, they're specifically looking at it at a more broad level. And so it made sense to kind of say, hey, let's keep our scope as defensive. So it really is, if you look at the checklist, it's really looking at it more from a defensive, like how do I make sure that this doesn't cause harm being deployed into my environment? And then for the more complicated regulatory and governance piece of it, that will be up in the AI and privacy group. That gives people one place to go find that information.
It's great that you just said it that way, because my next question is, where is that place? Like, where can people go to find something when it happens?
Yeah, I'm sure we'll publish it in our newsletter. We'll post it on our site, our traditional ways of getting out information about our community.
Thanks for checking out This Month in Security. Again, I'm your host, Aubrey King with DevCentral, and I really hope you enjoyed it. If so, I hope you'd click like, or maybe even click subscribe, or consider writing a review or a comment. This Month in Security is a DevCentral podcast, community supported. Thanks again for stopping by, and we hope to see you next month.